Hello friends, good morning. So please confirm that you guys can see my screen, whoever is on WebEx. Please confirm that you guys can hear me and you guys can see my screen. Okay, thank you. So as of now, we are talking about Spark, and we have already seen how to write simple word count program. So let me, 1 minute, let me mute everyone. Uh, I'm muting everyone, mute on entry. Now I'm sharing my screen again. Okay, sorry that I forgot to mute. So I am taking you to the Big Data Engineer course. So even for you, after going through the class, the best place to refer is my course page. Here I have modularized in better way, and you can go step by step, and whatever is missing, you can just focus on that. So instead of watching this 1 hour, 1.5 hour video for the reference, it is better to go with these websites. Sorry, the website and the course page. The course page is the Big Data Engineer version, so Big Data Engineer immersion, and you should go through this. Okay, so as of now, we have already covered setting up Scala and SBT. I hope environment is ready for you. If not, we will troubleshoot. Couple of guys have already complained, and we will see how to resolve those issues. And you should be able to set up Scala IDE for Eclipse. You should be able to develop Spark apps with Scala IDE. And as part of that, I have shown you the word count program. And while defining the word count program itself, I have covered what is a Spark context and what is Spark configuration. And also, I have shown you map, the difference between map, filter, flat map. And also I have used the flat map and map as part of the word count program. And now I have already shown you the reduce by key also, but I haven't got into too many details about reduce by key, which I will be covering very soon. But this is how you typically develop the program. And as part of the, after applying the final transformation, as I have explained earlier, like in map reduce, you can actually write into HDFS directly from the reducer. Whereas here, after applying all the transformations, whatever RDD is generated, you can apply the appropriate functions to write into the underlying file system. Okay. So there is no way you can actually write the output which is generated by reduce by key directly into the file system. We have to apply the appropriate API or function on this RDD. This is also RDD which is generated after reduce by key, which have the word count, and we have to use appropriate API to save it into underlying file system. And this is how you do. So WC reduce dot, on RDD there are some functions which starts with save. Okay, so if you say save as text file, it will save in the form of text file. If you want to save as some Hadoop supported file system, so Hadoop out of the box supports some file formats, not the file system, file formats. Those are key value pair file format, nline file format, and there are few more things. Okay, so if you want to use any of those Hadoop file formats, you can use save as Hadoop file or save as new API Hadoop file, and the RDD will be saved into the Hadoop supported file format. There are two. One is Hadoop file, one is new API Hadoop file, because there are two APIs in Hadoop. One is legacy, which is being deprecated, such as so save as Hadoop file is the one which is pointing to the older APIs, and save as new API Hadoop file is the one which point to the new APIs. So the only thing you need to remember here is don't use save as Hadoop file. Instead, you have to use save as new API Hadoop file to write into Hadoop supported file formats other than text file, object file, there is one more sequence file, etc. If you don't want to use this text file, sequence file, or object file, but the other Hadoop supported file formats, you have to use save as new API Hadoop file. Okay. That being said, here I will be showing only save as text file for now, and it takes path as parameter, and we have to give a non-existing directory path as we have done in HDFS. In traditional MapReduce also. In traditional MapReduce also, we have, while running the program, as part of the parameter, to Hadoop jar file name, and then input path and output path, we have passed the non-existing output path, or the directory pointing to the output path. Here also it's the same thing. You cannot directly pass the directory which is already existing. You have to either handle the situation, or you have to add a non-existing directory directly. So for now, I will just hard code it. So the hard coded value is this one, research, and I'll be saying output word count. Let us confirm that there is no directory with that name. There is no directory. So now we have this logic of saving it into text file. Okay, and then everything is hard coded, so we don't need to pass anything as parameter, which is not a good practice. I will explain what are the good practices in a moment. Run as Scala application. I didn't save it, so it just pop up to save. It will save now, and it is running the program. Okay, it seems it is executed. Yes, it is executed. We are able to get into the directory now, and you can see the word count file here. You can cat on it and see the output. Okay, so if you want to change, so here the reduce by key generates tuples of key which is nothing but word, and the value which is nothing but the word count. Okay, if you want to change the behavior, instead of saving the toString of tuple, if you want to save it in a different format, okay, what you have to do is you have to apply a map function on top of it. Map, do the necessary transformation. So in this case, instead of saving it as tuple, I want to save it as tab separated value, or plain text with comma separated. Whatever delimiter you want to choose, you can choose. Here I will be using the tab separated. So like, I will explain what is this _1 in a moment, and then we can concatenate saying plus. Here I want to save it, concatenate with the tab plus reg dot _2, and then the output of the map is again RDD, so we can apply the save as text file on the RDD. Okay, this is how you can actually write into multiple lines. Okay, I will come back to that question in a moment. Let me delete this directory now. Okay, now I'm running again. Run as Scala application. Done. Now you can see that the values are tab separated. So there is a reason why I'm emphasizing on this. Recently, one of the student, he got confused. So the question in the certification is to save the output in a tab separated format, and he got confused and he actually applied the save as text file directly on the RDD, and then it is marked as incorrect, and he could not clear the certification. There are other issues also. He could not get the 70%, and he could not clear the certification. So always remember what task you need to perform. If you have to perform a transformation, so in this case, we have to change the tuple, which is so tuples. The toString functionality of tuple is to just print within the circular braces. So if you try to directly save the content as is from the RDD, whatever is the representation in the RDD, the same thing will be written into HDFS. Okay, but if the question is to write into a different format, if the data has to be saved using a different delimiter instead of writing it as tuple, if you have to write it in something some other format, then you have to understand that it's a row level transformation on the final RDD. For the row level transformation, always you should use the map function, and only then you have to save as text file. Okay, so make sure you remember the relevance of the map, filter, flat map, and also the other transformations which I will be covering today. Okay, so now we have written a complete MapReduce program, and sorry, a Spark-based MapReduce program to generate word count, and it is not a very good practice to hard code like this. We have to save few of them as parameters, such as input path, output path, because at runtime they change. So it is a good idea to pass them as parameters. But this one, the set master, set application name, these things you should not pass as parameters, or you should not hard code, because it might change. For example, for the application name, you want to run you want to generate a unique name for every run, for whatever reason. In that case, you should not hard code. The base string should be passed as a configuration parameter, not as runtime command line arguments. You should not pass these things as runtime command line arguments. It's better to pass them as configuration properties for your application. Same as this one, set master. When I run with Eclipse, I want to run as local. When I run it on cluster, I want to run it in yarn mode. Okay, so based on the environment, I might have to change the way I want to run the program or the application. For that reason, we have to we should not even hard code the way we are going to run our application. All these things are considered as configuration of our application, and you have to externalize these properties into some external configuration file, and you should load at runtime, and you have to get those values at runtime, and you have to use those at runtime. Okay, here I will not show line by line example, but if you go through my website, and if you actually when we actually go through these transformations and actions, we will see that as example. I think even in a word count program which I have used here, I have covered that up to some extent. Let me have a look at that. No, here I'm just passing everything as arguments. There are, but the main use case which I try to explain here, I have used the externalization features. I will so even as part of the next demo also, next demo of the next application which we'll be developing, I will be externalizing the parameters, but I will not be probably explaining in detail. When you go through this material, when you start using this as reference, you will understand all those concepts in detail. Okay, we will limit to Spark based stuff as part of the class. For the other relevant information, you can go to the material, and if you have any questions, you can ask. Okay, and it's not very complicated also. You will understand very easily. Okay, so now we will get on to the next topic, RDD. before that, I will take few questions here. Raj have already asked, after one set of map and reduce, can we take the output, reassign another set of map and reduce? Yes, and that's what I think I have done here. Here we have to apply the transformations on the output, and we have done that. And you need to make sure that you design properly and avoid as many steps as possible. Okay, if you don't do that, then you will not you will be writing a inefficient application. It might work functionally, but it might be inefficient. So you need to make sure the design is correct, and you have to follow the design and reduce the number of map reduce cycles, and that is called as chained map reduce program. Your application typically will be a chained map reduce application. You cannot accomplish everything as part of one map reduce lifecycle. When it comes to Spark, you might do it any combination. In this case, we have done map reduce map. Actually, in this case, we have done flat map, map reduce map. So it's different. You don't have this much flexibility when it comes to traditional map reduce. Traditional map reduce is always map reduce, map reduce, map reduce, map reduce. Here you will have a lot more flexibility. You can interchange the way you want. Okay. So yes, in this case, flat map is mandatory. The reason is we have to flatten out the array into individual records, as I have explained as part of the earlier class. So Jnana Prakash have asked the question, is it mandatory to have flat map? Okay, you can do it without flat map also, but as part of the best practice, you should use flat map. Flat map is intended for these scenarios. If the output is an array, and if you want to flatten it out, and if you want to process each element in an array as a different record, then you have to use flat map, and it is very appropriate for use cases like word count, and we have to use flat map as a better practice. Okay, there might be other way also to deal with this, but this is the better practice. So next we'll get into the RDD, the concepts behind RDD. Okay. So RDD stands for Resilient Distributed Dataset. I have already explained what it is. In this case, I will show you how to generate these RDDs. So Jiva is asking, that is correct, Jiva. Jiva is asking, curly braces are used for multi-line purpose. If it is not multi-line, we can use circular braces. Yes, that is correct. Oh, okay. Sorry, Jnana Prakash, I did not get your question. Thank you, Jiva, for correcting me. Yes, the curly braces is not mandatory. In this case, you can use circular brackets also. Thank you very much. Okay. So there are multiple ways to create the RDD. For practice purposes, you don't even need to read from the files the way we have done. But typically, it's always better to focus on the files. But you should also know how to generate RDD from a collection of a Scala. So here, data is nothing but a array, which is data structure of Scala. It's not Spark related feature. It's just Scala based stuff. And if you want to create an RDD out of it, SC, which is Spark context, have a function called parallelize. So this parallelize will actually create RDD of the collection. Okay, so the only reason why you should focus is probably because of the certifications. Typically in the actual projects, you don't create the collections as part of your application. You always read the data from external file system, such as SDFS, S3, local file system, etc. And then you will create RDD out of it directly, and you can apply the transformations. But as part of the exam, as part of any of the certification exam, there is a probability that they might give a collection, and they might ask you to create an RDD out of it. Okay, in that case, you need to be familiar with this parallelize. So that's the only scenario where I can see in real world, where the RDDs will be created out of the collections. There might be some other extreme cases, but typically we don't do that. So make sure you understand that there is an API called parallelize, and use those things. And one more thing you need to remember is, especially when you are using Scala, if you have to write the programs using Spark Shell as part of the certification exam, okay, there is a autofill feature as part of Spark or Scala. It's feature of Scala, I guess. You can leverage that. Here SC is the object which is already created, and you can type and hit tab, and it will autofill automatically. If there are too many, if you hit tab twice, it will show the simple usage also. If there are too many, here after SC dot, I just hit tab, and you can see that there are many functions on SC, which is Spark context object, and you can get the help from here. So you can see there is a new API Hadoop file, parallelize, and many more things. So if you are not sure, you can type the object name dot, and you can start typing and hit tab to autofill. So sc.text file is to read the files from HDFS or S3. sc.parallelize is to actually create an RDD out of the collection. Okay, make sure you have that in mind. And this works only with Spark Shell, which is in Scala context. This does not work with Python. Can you guys hear me? Hello, can you guys hear me? So everyone else can hear, so we will proceed. He will reconnect. Okay. So this actually show the rest of the steps about how to create RDD from the other file systems. Sometimes one more thing you need to keep in mind when you are trying to read the file system, the default file system might change. We will see when we actually run the application, the next application, about these things in detail. But here I want to emphasize, because we are talking about creating the RDDs. So if you go to if you launch Spark Shell on my machine, so at this time I'm using Spark Shell on my machine. Okay, and here I don't have a Hadoop cluster or anything. It's running in local mode, and it actually runs in. It is only capable of reading files locally. It cannot read files on HDFS. If I configure it, I can read files from S3. Okay, so you need to understand the protocol here. Okay, as I have mentioned to you earlier, Spark can read files from different file systems. It can read from S3, it can read from HDFS, it can read from local file system. So if you don't define protocol, so whatever it is configured for the default, it will try to read from that file system, from whatever is the default. In this case, when I have configured locally everything, the default file system is my local file system. So now, if you see here, when I try to run sc.text file as part of the application, because Eclipse is also running in local mode, so directly it will point to the local file system, because that is the default. Same thing if I go to the cluster. So here I am logging into the cluster. So this is the CloudX Lab cluster. Here, if I launch Spark shell and hit enter, it typically run in the cluster mode, or it is already configured with HDFS directly. So the default file system will be HDFS file system. Okay, so if you want to read the files that are in local files, you have to say sc.text file colon ///. Uh, so this is the protocol how you can read the local file system. And the local file system starts with means the Linux file system starts with root, which is represented by the / itself, and then you have to give the path. So for example, here I am in this location pwd, and I have a file which needs to be read. Okay, so we can copy this one, and these are very important for the certifications, because especially people who are from mainframes background or who are not very proficient with Linux, they make these silly mistakes and it can cost the exam. Okay, so you need to keep these things in mind. So here, if I have to read files from the local files, what I have to say is file colon //. So this is how I can read from the local file system if the default is not local. And then my actual path is /home/training8634. So this is my path. So I have to give the fully qualified path after file colon //. And if you want to pass directory, you can give up to that directory. If you want to pass the file itself, for example, loadcount.txt, you have to use that like this. Okay. So this is how you can actually read files from the local file system, even if your local file system is not the default one. Okay, if the default is S3, for example, on the cluster, if the default is S3, and if you have to read the files from HDFS, then you have to use like this. So you have to give HDFS colon and // and then IP address of the name node, because we are trying to read the files from HDFS. Name node is the only one which can actually map the files to the blocks where we have the data physically. So we have to give the name node IP address colon. Typically, the default port number is 8020, and then you have to give the HDFS file system. If your Spark is not integrated with the HDFS, or if it is pointing to something else by default, and if you have to read the file from HDFS, you have to read it like this. Okay, so this is the URL for your name node, HDFS colon // IP address colon port number, and this is the location within HDFS. Okay, and actually up to this is the location up to data. And one more thing you need to keep in mind is, if you are not sure about the HDFS URL, what you can do is you can go to the etc Hadoop conf directory if you have access to it, and go to coursesite.xml and hit enter. Here you will get the HDFS URL. The parameter name which will give that value is fs.defaultfs, and this is the exact URL which you need to use. Okay, so if it is the sandbox, it will look like this. If you go to that file and have a look at it, you will see something like this. If it is a cluster on CloudX Lab, it will look like this. So you just have to use that string here to point to the HDFS. If it is S3, Amazon have a file system called S3, which is a cloud-based file system. And if you have to use that one, there are certain steps which you need to follow. So you have to use S3 as protocol, and you have to give path as per the S3 specifications, and also you have to authenticate to access the files, you have to pass something called access key and secret key, and there are multiple ways to pass that. So one way is by setting up the parameters related to S3 for access key and secret key, and then reading using sc.text file. You can do that using conf object, conf.set, give the appropriate parameter name. There are two parameters which you need to pass, which will help you to authenticate with the S3, because it's a cloud-based file system. If someone have to access the files, the files might be privatized, and people have to authenticate to that file system, and that access key and secret key are mandatory. You can Google for S3 and you will understand about it in detail. I also have some videos in my channel. Okay, so this is how you can create RDDs from different file systems. As I have explained earlier, RDD is nothing but an in-memory distributed collection where we can apply several Spark-based APIs for the transformations and actions. Okay, and when you issue the sc.txt file, when it is executed, when you submit the job, it will actually load the RDD into load the data from files, whether it is on HDFS or S3 or local files, into memory in the form of the distributed collection called RDD, and then you can expose that RDD for any of the APIs to do the necessary transformations. Okay. Now we will get into the transformations and actions overview, and then we will define the problem statement, and we will start developing more sophisticated application close to the real world scenario. Okay. So typically the transformations and actions are used to read and write from HDFS. Okay, it's the operations on RDD, which I have already covered, and we will do joins. We will aggregate. So if you have multiple data sets and if you have to apply the transformations, first you have to do the join, and then we typically aggregate the data set. We will filter, which I have already covered, and the final thing is sorting and ranking. So all these things are the transformations which you need to perform in any project. Okay. So these are the actual APIs which you need to understand to do all these tasks, such as joining disparate datasets. We have to use an API called join. Okay, and if you want to do the count, you have action called count, and there is another action called reduce. If you want to get the sum of a particular field on all the records, you can use that. As I have explained earlier, if you want to do row level transformations, you can perform map, flat map. If you want to cleanse the data, you can by filtering out the unnecessary records, you can use filter. And then for aggregations, you can use any of these things. If you just want to get the count, so these are for by key aggregations. These are total aggregations. Count and reduce are for total aggregations. And if you want to perform certain aggregations by key, okay, such as count by key, sum by key, average by key, minimum by key, maximum by key, in those scenarios, you have to use transformations such as count by key, group by key, reduce by key, aggregate by key. Okay. So if you think about a life cycle of an application, typically we read the data from the file system, we apply row level transformations, join the data sets, aggregate the data, and this might go in multiple cycles. Okay, some of the steps might be discarded, and for example, you might apply row level transformations, join the data sets, and then again you go to some other row level transformations, then you might go to aggregate the data. So these three steps especially, it might go in multiple cycles in multiple combinations. It is very important to understand that. Okay, and then you can sort the data, and then you will be writing the output back to the file system. So there is a question: is there any transformation equal to router transformation of Informatica? I need to understand what the router transformation does, and based on that, I can provide the answer. I'm not familiar with the router transformation. Okay. On top of this, there are other transformations also, such as co-group, union for set operations, and all those things. But union and the set operations, co-group, all might not be used as frequently as we use these transformations. But you need to have a fair idea of all the transformations, And before designing your application, you have to review the transformations that are available and choose the transformations that are applicable for your business case, business requirement. Okay. And now we'll try to understand our data set, and we will try to define a problem statement, and we will see how we can actually uh, implement that problem statement. So the question from Jiva is, I think in your local system, the Spark version is 1.6.2 and Scala version is 2.10.5. But in the build.sbt, you have mentioned the Scala compiler is 2.11, how it works. Okay, so there are a very good question, Jiva. Okay, so on my local file system, I have, so this is actually a cluster. If I come out of the cluster, okay, I have Spark 1.6.2, which is built using 2.11 Scala. So there are two things which you need to understand. One is, what is the Scala version used to build Spark, and the one is, what is the Scala version which we are using to use to build the application. There are two different things. Okay, in this case, when I actually create the application, research live demos, big data, Spark, Scala. Okay, so this is our build.sbt. Okay, on my PC, I have the Scala version 2.11.8. Okay, but what I'm saying is I have created the library dependencies. So the Spark which is being used depends upon the plugin which is defined here when we actually execute the applications using Eclipse. Okay, so here whatever I am using Eclipse is independent of whatever I am running using Spark Shell command. Spark Shell command, I have Spark installed differently, and when I use Spark Shell, it will connect to that. But when I use Eclipse, it will try to connect whatever dependencies that is defined here. It will download those dependencies. So those jar files you can see here, Scala library container. Okay, this is the old one. This is the new one. Forget about the demo Spark Scala. That is the existing one. The new project is this one. Here you can see that Scala container is 2.11.8. Okay, and the referenced libraries, all the Spark related stuff will be displayed here. Spark Network Shuffle, Spark Core, you will see many of those things as part of these jar files. Okay, so here whatever we have defined as dependencies, when I try to run using Eclipse or Scala IDE for Eclipse, it will try to use. So it is completely independent of whatever I am doing under Spark Shell. So Spark Shell is, I have deployed Spark separately on my PC. Okay, that being said, if you go here, I am trying to build the applications pointing to Scala version 2.11.8. Okay, and when it comes to dependencies, I can use Spark Core, which is built using 2.11 Scala or 2.10 or whatever version I want. So I'm trying to use Spark Core 1.6.2, which is built using Scala 2.11. Okay, whatever jar files which are created here, September 2016, whatever you are seeing as part of the referenced libraries, you can see Spark-core 2.11 1.6.2 jar. Okay, and then on the cluster we have 2.10. We don't have 2.11, but still this application will work. When I compile it into a jar file, already the jar file will not have any of the referenced libraries. Okay, even the build.sbt will not play any role. Okay, it will build the jar file, it will ship the jar file to the, means we need to ship the jar file to the cluster, and we need to run that on the cluster. If the compiled classes are backward compatible, or the versions are compatible, it will work. If the versions are not compatible, it will not work. For the use cases such as word count, where we are not using any advanced features of Spark, it will definitely work. Even though I am using 2.11, the Spark core, which is built using 2.11 Scala for 1.6.2 Spark, and on the cluster it is using 2.10, still it will work, because there is not much difference for the core Spark between these versions. But if I use data frames, in that case you will run some issues. So you have to make sure that the binaries which are used to compile your classes or your jar file is compatible with the Spark version you have on the cluster. If they are not compatible, you will run into issues. So first you have to troubleshoot from there if there are any issues. Okay. So to answer your question, as long as it is backward compatible, or as long as the versions are compatible, it will work. If the versions are not compatible, it will not work. And here again, my application I am compiling using Scala 2.11.8, but the Spark core which is being used as part of my application is compiled with 2.11, but it could be compiled with other version also. So there is no issues with that. You can use whatever jar files you want. Yes, in my PC I have installed Scala 2.11, and I'm using the same Scala. I have environment variables for Scala home and all those things. So I'm using the same 2.11 Scala. Even in my Eclipse, you can check which compiler is being used when it comes to Scala compiler from here. Okay. By default, it uses the latest bundle. If you want to change the settings, you can go here and you can change it. Okay. If you want to compile with Scala, but don't change it here, leave as is unless you run into some issues, and try to control using SBT. Okay, whatever you have defined in SBT, it will automatically use those things internally. Okay, so there is one question from Ramesh. It's advisable to configure the Eclipse according to the target instance. Yes, it is. They have to be compatible at the least. If not the same, at least they have to be compatible, and there should be another environment before production which matches with production, such as testing environment, irrespective of whatever binaries you are using as part of your development environment. You have to test it first in the testing environment, and then you have to roll it into production. And the testing environment should be similar to production when it comes to the binaries which are being used to run your applications. Your cluster configuration might be different. Okay. So that being said, now let us get into the data. Let us understand how the data look like. So the data set which we'll be using is from retail_db. This data set is provided by Cloudera itself. If you go to Cloudera Quick Start VM, there is a retail_db database in MySQL. And I have used the same data set, and I have generated GitHub repository for that, which is comma separated, so that the Spark module is independent and you don't need to import the data from MySQL to process the data. So for that purpose, first you have to do is you have to go to this GitHub account. Okay, there is a repository called data. You can again use git clone command. I think I have explained already, or you can actually download into zip, and you can unzip the file, and you can unzip the zip file, and you will see a directory called retail_db in that. And that retail_db have 6 files, so 6 directories: categories, customers, departments, order items, orders, products, etc. And here you can see the actual files themselves. So these are all plain text data where the data is comma separated. So I have already downloaded into my local file system research data ls-ltr. So this is the retail_db which I am talking about. If you want to run the clone command, what you have to do is click on the repository. So these are all subdirectories under the repository. Actual repository name is data itself. Okay, expand this one, copy this one. If you have Git client installed on your PC, you can just say git clone and paste the URL, whatever string you got it from there, and it will download the files for you. And then you will see directories like this, and retail_db is the one which we are interested in. And here you can see the directories: products, orders, order items, departments, customers, categories, etc. And to preview the data, you can go to one of the directories. Departments is the smallest one, and you can see there is a file called part-00000. Okay, you can discard these hidden files. I will delete from the repository also. We are just interested on these files, and you can actually view the file. You can see that it's a 2-column data set. The first column is department ID, second column is department name, and the fields are comma separated. Okay, and to understand the data model, I think I might have copied the data model to here. Yeah, so you can see the data model here. Right click on this and open image in new tab so that you can get a bigger bigger version of it. Okay, so this is the data model. I'm not sure whether you are familiar with the data model diagrams. Okay, so and there is a concept of relationships. There is a one-to-many relationship, many-to-one relationship, and many-to-many relationship. Okay, and in a normalized database, between two tables, you always have one-to-many relationship. Okay, so in this case, and also typically tables are categorized into transactional tables and the metadata tables or master data tables. So in this case, orders and order items are transactional tables. Customers, products, categories, and departments are master data tables. So customers table will have the customer details such as customer ID, which is unique ID for the customer, his name, email ID, password, and address. So those are the details customers table have. Products have all the products that are being sold by the retail platform, and then products can be categorized. So, for example, if you think about a major retail store where they sell groceries, apparel, sport goods, home goods, etc., and there will be categories, subcategories, etc. So in this case, the electronics, apparel in a major retail store can be categorized into departments. Grocery, apparel, all those things can be categorized into departments. And within groceries also, you can actually have the categories. So there could be multiple levels of categories, subcategories, etc. This is smaller data set. Hence, we have departments at a higher level than categories, and each category will have the products. So there is a one-to-many relationship between departments and categories, and that this is the representation of one-to-many relationship. When towards the parent table, where there will be one record and there can be many records in the child table. In this case, departments is the parent table and categories is the child table. And for each department, there can be many categories. So there is a one-to-many relationship between departments and categories. Okay. So this is how the one is represented, and this is how the many is represented in the ER diagram. It is called as ER diagram, entity relationship diagram. Okay, and this is how one-to-many is represented. So categories and products have the one-to-many relationship. Products to order items have one-to-many relationship. Orders to order items have one-to-many relationship. I will explain orders and order items in a moment. Orders and customers have many-to-one relationship, or customers and orders have one-to-many relationship. Okay, and then as I have mentioned to you earlier, orders and order items are the transactional tables. So when you go to a website such as Amazon, and when you try to place an order has to be mapped with a customer. So you need to have a associated customer details. So for each order, there will be a customer associated with it. Okay, but one customer can submit multiple orders. That's why there is one to many relationship between customers and orders. Okay, and what are the attributes of orders? Typically, we'll have an order date when the order is submitted, and the order customer ID, whoever is submitted the order, and order status, whether it is completed, pending, or new, etc. Okay, but when you go to Amazon, typically you might end up buying multiple products. Okay, most of the cases you will end up buying multiple products. Those multiple products within orders is called as order item. So an order can have one or many order items in it. So to specify the attributes related to each of the order item, we have created an order item table. It has order ID, which is a foreign key to orders. Order items is a tail table to orders, and order ID is the foreign key to orders. And then product ID. So whatever is product in each item. And sometimes if you are buying apples from a grocery store, you might buy in dozens rather than weight, right? So in that case, if you want to specify the quantity, you can do that here. Or water cans, you will buy in quantity for sure. So if you want to buy 2 water cans out of the platform, you can specify the product ID of the water can, and you can specify the quantity. Subtotal is first let me explain the product price. Product price is the actual price of each of the product, and subtotal is nothing but quantity into product price. So these are the information at order item which is captured here. And then orders, we have order level details. Order items, we have order item level details, and order items is the tail table for orders. So whenever an order is placed, typically data will be inserted or updated in these 2 tables. Whereas customers, products, categories, departments are master data. Only when new customers are being added, customers table will be inserted or updated. Only when new products are added to the catalog, your products table will be added. Only when new categories added, your categories table will be updated. If the department is added, your department table is updated. These are all master data which don't change that frequently, but these 2 are the transactional tables. Okay, it is very important because this is the foundation for the most of the analytics stuff. You need to understand that typically in the source system, if it is RDBMS, it will follow the normalized data model. Now I will take a simple example. So here I am trying to give a primer about the dimensional modeling and how it is different from the normalized data models, which are part of the traditional transactional based systems. Okay, when it comes to dimensional modeling, so let's say you want to build an enterprise data warehouse and you want to publish reports out of that. So what are the reports that are relevant for the executive management? He might want to see how each department is performing on regular basis, on daily basis. So which department is performing, and he might want to see the trend. Okay, so in this case, if we have to build the report out of the existing transactional system itself, you have to join departments with categories, categories with products, products with order items with orders. And then by joining all these 5 tables, we have to run the query, and we can get the report which we are looking for. But when you are trying to do on a very large database, even if it is 10 GB or 20 GB also, even if it is not a very big store, and if you have a handful of orders, etc., joining all these 5 tables and generating the report can impact the OLTP system, because it will do full table scans. It will saturate the resources to which has to support your actual business will be impacted when you join these tables for store level or company level aggregations. So we don't report directly out of the OLTP systems. Instead, we will do the ETL, get the data into downstream systems such as ODS and EDW. And in EDW, Enterprise Data Warehouse, we will create the models based on dimensional modeling so that the reports can be faster. Okay, for example, I can copy the entire data from all the 5 tables into EDW and I can generate the report. It will not impact the source application, but still your report will not be very efficient. It will take time. Whenever you change the attributes in your report, to refresh that report, it will take a good amount of time. Okay. And the tables can grow significantly over time, depending upon the SLS. If you want to store the entire data for 7 years, your table can grow very large. And if you have to generate all the reports out of those tables, and that too with joins with other tables, even though it will not impact the source system, still your reports will not be very fast. So let's take the example of the same thing. I want to generate the revenue of for each department for each day. Where is the date? It's in orders table. Where is the revenue? It's in order items table. Where is the department ID on which we want to aggregate? It's in departments table. Okay. And apart from those 3 fields, we don't need anything else. So what we can do, we can get the data on daily basis. We can capture the delta, and we can discard all the other fields. We can perform the joins at the time of the transformation, and as part of the table which has to support the report, we just need order date, order subtotal, and the department ID. We don't need anything else. So to support your reports, you already pre-process the data. You can do the processing at the request time, or you can process the data at the transformation time when the delta is being loaded. And 90% of the scenarios, it is always better to process the data as the data is being loaded into the downstream applications, so that you don't need to do the processing, or you can minimize the processing that is required at the request time. So you need to understand the request time and the ETL time, or load time. Okay, so the transformations includes those aggregations to support your reports in the downstream. And to there also you have to model. You have to create some data model following certain concepts, and that data model is called as dimensional modeling. There you will hear the terms called fact, dimension, star schema, snowflake schema. If you are aiming for the data engineer role, you have to understand those data warehousing concepts, and it will come handy in many ways. Not just from the big data perspective, it will come handy in many ways. You need to understand the term called ETL thoroughly, the difference between the normalized data model and denormalized data model. And most popular denormalized data model is called as dimensional modeling, where you will see facts, dimensions, hierarchies, etc. Okay, so there is a question. Do you have any videos for data model? No, I don't have any videos for the data model. For now, you have to refer something called Data Warehouse Toolkit for dimensional modeling. Okay, that book have use cases from different industries, and they not only explain what is a fact, what is a dimension, etc. For the respective industry, they also identify what are the most appropriate facts and dimensions to start with, and then based upon the requirements, you have to add more facts and dimensions. So these are the things which you need to understand: fact, dimension, star schema, snowflake schema, data mart. These are the terms which you need to understand. On top of that, you need to understand what is ETL is. We are hierarchies. So these are the things which you need to understand. Okay, slicing and dicing, or drill up and drill down. Okay, so these are the core things which you need to keep in mind. And also there is another thing called cube. So what is cube is in traditional BI tool, sometimes to start with the project where the transformations are done before all the aggregations are done as part of the ETL, to implement that project, it's very expensive. So we can actually connect to the source database and create a cube Okay, cube is nothing but a denormalized data which will be cached in the BA tool. So to avoid the expensive life cycle of implementing complete EW for simpler reports, you can use features such as cube, which are part of BA tool, where the transformations are typically done at runtime. And also, it does not hit the source system for each and every query. It will cache the data for the first time in the in memory or the file system of the BA tool, and from there it will support the reports. But cubes are not very efficient when it comes to dealing with larger data sets. Up to some extent, it works well. Okay, so these are the things which you need to keep in mind as a to become a data engineer. Okay, so I have any questions on these tables? Let me know. I will answer that question. So now we understood the data model. We'll go to the next topic, defining the problem statement. Okay. So this is the life cycle of implementation of a project. We have to define a problem statement. We have to design the application. We have to implement, test and validate, and we have to build and run on the remote cluster. Okay. So here we have 6 tables in our data set. We would like to see average revenue for each day for all completed orders. Okay. So for that, you have to preview the data. You have to understand each and every keyword as part of the requirement. The requirement is, so this is how traditionally the executives will give the requirement to the IT team when it comes to generate the reports. But there will be a role guy called business analyst who can understand this and who can translate it into a technical specification. But slowly that gap is minimizing, and the IT professionals themselves have to play the role of business analyst. So anyway, we will play the role of business analyst now, and we will try to understand the business requirement and try to come up with a technical specification, and then we will start implementing it. So the requirement is we would like to see average revenue for each day for all completed orders. So here we have to emphasize on average revenue. At what interval we want to see it for each day, and what are the orders we want to see only for the completed orders. Okay, first we'll go with the completed orders. From where we can get the completed orders? It's from orders table. There is a field called order status. So we have to discard all the other orders which are not in complete state. So we will go to the departments here, orders, and we need to understand how the data is represented in that table. Okay, cat. You can see that it's typically in the caps, and completed orders are mentioned as complete. Okay. If typically in traditional projects, in actual BA or enterprise data warehouse projects, there could be some standardization issues, and you might have to take care that before actually generating the final report. And those standardizations, data cleansing, filtering, all those things has to be taken care as part of the ETL itself. When the data lands in your data warehouse, you need to have the standardized data so that your filtering or any other transformations can be easy. If data is not standardized, if multiple source systems follow different standards, then your report development will get complicated. For that reason, you have to take care as part of the ETL itself. It not only complicates the report development, you will see many inconsistencies and unforeseen issues such as performance when you have non-standard data. So it's very, very important that you standardize all the data before loading into the downstream applications such as EW in the form of fact tables. Okay, so order status is from orders. So the next thing is for each day. So we need to get the order date. Orders is the table which have the order date. And then we want to see average revenue. So the revenue is in order items subtotal. Okay, so we have to use this one, and then order date and order status. And then for each date we want to see the so we want to filter out all the non-completed orders, and then we want to join, we have to join these two tables so that the date and for each date we can get the subtotal. Without joins it is not possible. Okay, now let's now let's come up with the design. Okay, so the design is read the data from orders and order items. There are two tables, so we have to read the data from orders and order items. Actually, I think design is here itself. Yeah, orders have order date, extract order ID and order date. Why we have to extract order ID? Because we have to join with order items. Without extracting the order ID, you will not be able to join. And order items have order item subtotal, and extract order item order ID and order item subtotal so that you can join. Again, order ID is only required to join between orders and order items. Compute revenue for each order. Okay, I will explain why we have to compute revenue for each order later. Because when I actually analyze the data, not all orders have entry into order items. So there are some orders which are in orders table but not in order items. To overcome that issue, and we want to generate, when I actually mention average revenue for each day for all completed orders, I want to consider only orders that are in order items. I don't want to consider the other orders. Okay, for that reason, to get only orders that are in order items, first I want to compute revenue for each order by using reduce by key transformation. Orders and order items have to have one-to-many relationship, one order to many order items. We have to join orders and order items. Then we have to get revenue and total number of orders for each day. Unless you do this compute revenue for each order, you will not be able to get the total number of orders directly. You have to again do something else, or you have to join two times. So to avoid the joins two times, first I have computed order revenue, compute the revenue for each order on the order items dataset, and then I am joining with orders and order items. By this time, we have order ID and order date from orders for completed orders, and we have order item order ID and revenue for each of the order. So we already collapsed the multiple items and we computed the revenue for each order in this step, and we have joined those two things. And then we need to get revenue and total number of orders for each day, and then we have to compute the average revenue. So this is the design which we need to follow. So here we have to use filter to get completed orders. We have to use map function to get order ID and order date. Okay, we have to get revenue per order item per day using reduce by key. We have to use join to join orders and order items, and then we have to get order count per date from order items. It's an aggregation, and here we have to use something called aggregate by key, and then we have to yeah, this is where we actually this is where we actually get use the aggregate by key and get the revenue per day from the join data. Okay, so we need to follow these steps. And before getting into the implementation, now let us understand all the transformations that are required. For that, the best place is to go to the documentation, and we are using 1.6.2, so we'll be using the 1.6.2 documentation itself. Okay, so here we are getting into actions first. So actions are typically count, reduce, where we want to do some total count, total sum, etc. So we typically don't use actions unless we want to use collect take to preview the data. Typically, we don't use actions, but you should have knowledge of these things. They come very handy to preview the data, to explore certain things. But there are certain actions which we use frequently, such as save as text file, which you have already covered. So if you want to save the data into HDFS or any underlying file system, you can use the actions such as save as text file, save as sequence file, etc. Okay. So when the action is encountered, it will immediately run the program and it will take the action. So that's why it is called an action. So typically, your program will end with an action. So in the word count program also, we are using an action called save as text file, and actions are typically executed on the RDD. When the action is encountered, there is something called DAG, acyclic graph, which will be generated, and then that graph will be executed. The program will be executed as per the graph. Okay, and this feature of running the application when the action is encountered is called as lazy evaluation. It is supported by Scala. It is default in Spark. Okay, and even Python follows the lazy evaluation. So in Spark, it uses the lazy evaluation. So it will create the DAG for all the transformations and actions which are being created. And when the action is encountered, then the DAG will be executed. Until the action is encountered, it will create the DAG. Okay. You don't need to worry much about it at this time. You can revisit about DAG and how the execution happens a little bit later, and you can understand what is lazy evaluation, etc. little bit later. So for now, we will focus on the transformations and actions. Now comes the transformations. We have already seen map, filter, and flat map. So now we have many other things. We have union, we have intersection, we have distinct, we have group by key, reduce by key, aggregate by key, etc. So first thing, as per our design, if you go here, first I want to, up to here I have already covered, right? So we just have to use filter and map for the completed orders, and also to get the order ID and the other required fields for the downstream processing. The fourth step is compute revenue for each order. So when I say for each, that is the main thing which you need to keep in mind. When we say for each, that means we are trying to do something by a key. So we have to focus on by key transformations. So here we have multiple by key transformations. One is group by key, reduce by key, aggregate by key, and sort by key. Here we are not trying to sort the data. We are trying to aggregate. We are trying to get the revenue. So sort by key is eliminated. We should not use sort by key as part of our application. So there are three of them: group by key, reduce by key, and aggregate by key. So here the main thing which you need to understand is the difference between group by key and the other two transformations, other two by key aggregate transformations, such as reduce and aggregate. So the main difference between group by key and the other two are, group by key is more generic by key transformations. So if you want to do any custom implementation by key, you can use group by key. You can do sorting by key. You can do ranking by key using group by key. You can do aggregations by key. You can do whatever you want. Okay. Reduce by key and aggregate by key are specific to aggregations. You can do only aggregations. You cannot do anything else. You cannot do sorting by key. You cannot do ranking by key. You cannot do anything else, any other advanced transformations by using reduce by key or aggregate by key. Aggregate by key and reduce by key are specific to aggregations such as sum, average, min, max, etc. Okay, so that is the main difference. Group by key is much more generic, and it can do aggregations also. On top of that, it can do sorting, ranking, etc. Whereas reduce by key and aggregate by key are purely for aggregations. So now you have three things to do the aggregation. Our use case is aggregation, so we can use all the three. So which one we should use? We should not use group by key. The reason is group by key does not use a feature called combiner, which is very, very important when it comes to aggregations. So we need to understand what a combiner is, and then only we'll understand why we should use reduce by key or aggregate by key in our case rather than group by key. Okay, so I will explain about the combiner for today, and we will wrap up, and we will continue wherever we stop as part of the next class. So let me connect my tablet so that I can do whiteboarding here. Okay, here we need to understand common concepts of MapReduce again, and we need to understand the role of combiners, and we will understand how it is used as part of the aggregate functions such as reduce by key and aggregate by key little bit later. So again, we will go to the layman terms instead of talking about any technology here. So you have the data, a deck of cards. Again, I am talking about the deck of cards, which is divided into 4. And there are 4 people who want to process the data. Okay. And we want to get the count by suite. There are 4 suites, club, diamond, heart, and spade, right? So each one can have all the combinations of the cards. So what this guy, in typical MapReduce, what these guys do is they only group and sort the data. They don't do anything else. They only group. So we have 4 suites: diamond, club, heart, and spade, right? So each of these mapper. So let's say this guy's name is map1. What that guy will do, he will read one record at a time, and he will look into the data and see whether it is a diamond or club or heart or spade, and he will group, he will segregate all the diamonds or group all the diamonds, all the clubs, all the hearts, and all the spades into one group. So by the time he finishes his work, he will have all the diamonds grouped together, all the clubs grouped together, all the hearts grouped together, all the spades grouped together. And then when the reducer try to process the data, he will get diamonds from all the mappers, and first he will group clubs, hearts, and spades. For each key, he will get all the records and he will group. And then he will start processing. He will see, because the data is already segregated, for him, he just have to get diamonds from different mappers, and he just have to group them. It's very easy for him. He don't need to segregate. So the segregation from the reducer perspective is much simpler compared to the amount of work mapper is doing. And then he will actually start doing the count, and finally he will tell how many diamonds are there, how many clubs are there, how many hearts are there, how many spades are there. Do you think it is efficient? No, because this guy has to process. So let's say there are 1 million records, and each of them have 250K. Here 4 guys are working only on the segregation part. They are not doing any aggregations here. Only they are grouping and partitioning the data. They are not doing any aggregations. By the time the reducer get the data, he get all the 1 million records, probably 250K of diamonds, 250K of clubs, 250K of hearts, and 250K of spades. And for each key, he will try to add. So he has to do a lot of work. Rather, when the grouping and partitioning happens, if we can actually do aggregation here itself, okay, so all this is called a shuffle and sort phase. Okay, up to here it is called a shuffle and sort phase. Some shuffling and sorting happens on the mapper side, some shuffling and sorting happens on the reducer side. So as part of this phase itself, okay, from the layman term, if this guy himself actually not only group diamonds, clubs, and hearts and spades, but also if he can count how many diamonds are there, how many clubs are there, how many hearts are there, how many spades are there, now 4 people can do the aggregation. Okay, it's instead of one guy processing 1 million records to get the final count, Here 4 guys are processing 250,000 at a time. On top of grouping and partitioning, he is also doing aggregation, but the results are not final results, they are intermediate results. Now if they pass the intermediate results, instead of passing the information about after partitioning and grouping, if we can actually pass the intermediate results, now the amount of work reducer need to do is much lesser. And the process of aggregating on the map side itself, in the shuffle and sort as part of the map side itself, is called as combiner. Okay, and typically so the combiner logic can be same as the reducer logic, the combiner logic can be different from the reducer logic. Okay, the example where the combiner logic is same as the reducer logic is total or sum. So sum of intermediate values can is the final sum. So whether you add 1 million records, no, map side is join is different. This is called as combiner. Okay, we are only talking of combiner. Joins comes into picture when you have two data sets. Here we don't have two data sets. We are talking about only one data set, and we are trying to use the reducer logic on the output of the mapper. It does not execute as part of the mapper. It executes as part of the shuffle and sort if you get into the details about map reduce. This combiner will be invoked, and the logic whichever is defined in the reducer can be applied on this data to generate the intermediate results. Okay, in some scenarios such as total, so if you think about sum, okay, if you have 1 million ones, okay, 1 million ones, or intermediate values of 4 to 50 case, or 8 125 case, or 10 100 case, or a different combination of numbers is same. So as long as the intermediate values can be added to the to a final value which is equal to the sum of the discrete elements of the actual cards, actual data which we are processing, those are called as additive. And typically sum is additive, min is additive, max is additive. So min of means will be min, right? Min of intermediate means will be minimum value. Max of intermediate max will be maximum value. Sum of intermediate values will be sum. But average of intermediate values is not average. For example, if you have 100 records, 1 to 100, okay, you cannot compute the average of, let's say, 3 plus 4 plus 5 plus 6, and the sum will be 3, 6, 10, 15, 21. Anyway, I'm trying to avoid the decimals. It's very well known that average is not the will not give the correct average. Okay, what you have to do, if you have to compute average of average, you have to get the average and the total number of values which are used to compute the average, and then you have to multiply those two values and then add those values, and then you have to divide with the total numbers. For example, if you have 100 records, and if you want to process, if you generate 10 different averages, you cannot just compute the average directly. Okay, what you have to do, let's say in this case 1 2 3 4 5 6, which and we are using there are 6 elements in it. Okay, and it will result in 21 divided by 6, and it will give some average. How much it will be? 3.5. Okay, and similarly, if you have rest of the values, you cannot just add these values. Let's take 1 to 12. Let me open another page. Okay, let's take a simple example. 1 to 12. Or 1 to 10. Okay, and let's say if you want to generate intermediate values like this, or let's take all the even numbers between 2 to 10. So you have 2, 4, 6, 8, 10, right? So let's say you have 2 plus 4 by 2, 6 plus 8 by 2, 10 plus 10 by 2. There is only one element here. So this will be 3, this will be 7, and this will be 5. Okay. And then 1 minute. And then if you add this 3 plus 7 plus 5, it will be 15, and we have 3 elements. So 15 by 3 equal to 5. Whereas if you add these things and divide by 5 directly, so 6 plus 6, 12, 12 plus 8, 20, 20 by 20 plus 10, 30, which means 30 by 5. Yeah. 10 is directly 10. So we cannot actually, what will happen? 10 plus 7 plus 3, 20 by 3 will be some other number. But the correct average is 30 by 5, which is 6, right? So you cannot directly compute the intermediate values and use those intermediate values to generate the average. Rather, you have to either get the intermediate sum and intermediate number of values in the form of tuple. For example, for the same result, let's say we compute the total 2 plus 4 plus 6, which is 16, and we are using 3 elements to get the 16. Similarly, there is another 2 elements are processed, and 18 is the total, and we have used 2 elements. So if this is the intermediate values, we can use these intermediate values to compute the final average. Sorry, 2 plus 4 plus 6 will be 12, sorry. We can use these values to compute the average later. Okay, so the intermediate values are nothing but sum and the total number of elements used to get the sum. So here 12 is generated using first 3 elements, and 18 is generated using last 2 elements. Now, finally, what we can do, we can add these values and these values separately, which is 30 and 5, and we can divide 30 with 5 and we will get 6. Okay, so in this case, this has to be achieved by combiner, and this final logic has to be implemented in the reducer. So for the case of average, for the cases like average, the logic of combiner and reducer can be slightly different. If it is sum, it will be same, or min or max, it will be same. So we can use the same reducer logic as part of the combiner by using set combiner class as part of the MapReduce program. Okay, if it is different, we have to create another reducer, extending reducer class, and we have to set that custom class as set combiner class to get these intermediate values. So now the major difference from the performance perspective when you want to do the aggregations between group by key, reduce by key, and aggregate by key is that group by key does not use combiner. So it follows, if you use group by key, group by key, it will work the way I have explained without combiner. It will actually pass all the values to the group by key function, and you have to process and implement the custom logic to go through each and every record in group by and come up with the final aggregation. Whereas reduce by key and aggregate by key, they use combiner internally. Okay, unlike in MapReduce, traditional MapReduce, you don't need to specify what is the combiner class. If you use reduce by key or aggregate by key, which are specific to aggregation, they use combiners internally. Okay, and which one is for what? So I have already explained what I have explained. There are scenarios where the reduce logic and combiner logic are same, and there are scenarios where the reduce logic and combiner logic are different. So if the reduce logic and combiner logic are same, you have to use reduce by key function. If the reduce logic and combine logic are different, you have to use aggregate by key function. You can see that in reduce by key, it takes only one parameter. Forget about num task, which is function, where we implement the functionality such as this one to get the final result. Whereas in aggregate by key, forget this one for now. You have two parameters, sequence op and comb op. So sequence op, you have to pass the combiner logic as part of the sequence op, and you have to pass the reducer logic as part of comb op. So the wording is a little bit different. So they call it a sequence operation and combiner operation. But as part of the combiner, if you try to compare with the traditional map reduce approach, we will be implementing the reducer logic here, and we will be implementing the combiner logic here. Okay, so that's the difference between reduce by key and aggregate by key. It takes two parameters, one for combiner logic or sequence operation, and reducer logic or combiner operation. Whereas reduce by key, it takes only one function, where the same logic will be implemented as part of the combiner as well as the reducer. That's the difference between reduce by key and aggregate by key. So here, coming back to our problem statement, we want to just compute the revenue, revenue for each order. So we just have to implement the sum logic, and we can do that. We can use reduce by key because the combiner logic and reducer logic are same, and we can get the revenue for each order. Then we can apply the join operation. So again, if you go back to the transformations here, we have many others. And to join the data sets, it's pretty straightforward. You just have to use the join function. It supports left auto join, right auto join, full auto join, etc. In this case, we'll use only the natural join or normal join. We don't use any of the auto joins. And then after joining the orders and order items, we have to get revenue and total number of orders for each day. And here we will use the aggregate by key because the combiner logic and reducer logic are different. And then we have to compute the average revenue at the final step. And we will see all those things as part of the tomorrow's class. Today we have gone through the data model. We have defined the problem statement. We have understood what transformations we should use. And tomorrow we'll go to the implementation for this problem. Okay. So that being said, I will take few questions here. Already Ramesh have asked the question, by using combiner, we are offloading some of the reducer work at map side to avoid large data transfers over network to increase performance. Yes, that is correct. It's an accurate statement. Okay, so there are few issues raised yesterday about not able to bring up the bring up Scala ID for Eclipse, or some other issues related to environment setup. I will go through that. Before that, last week many people have raised the issue, say about the null pointer exception when they use Eclipse for Java MapReduce. So I have reproduced the problem as part of my PC. So the problem is so let me explain you. So I'm switching the workspace and going to Java MapReduce workspace. Okay, so this is one which you are using. So if you go to pom.xml, the dependencies are mostly from Apache. So when you download from the Apache and when you try to use or when you actually create dependencies from Apache, and when you try to process Windows file system, the file system on Windows, you are supposed to have some native libraries. So those native libraries are not out of the box when you actually define the dependencies in your pom.xml. So rather than that, the workaround which I have come across is use the Cloudera repositories. Okay, So the Cloudera repositories already have the native libraries compiled for the Windows file systems. If for that, what you have to do is you have to create a repositories. I will share the pom.xml today with you. So you will find the repositories here pointing to the third-party Cloudera repositories, and then version, it will be like 2.7.1 or 2.6.0 hyphen cdh 5.2.x, something like that. Versions will be more Cloudera oriented. Okay, but when you write, most likely there shouldn't be any issues when you try to run the applications on Hortonworks cluster, even though if the binaries are compiled with Cloudera. If you start running into those issues, then you should not use that approach. Okay, it's Windows problem primarily, and Apache does not provide native libraries out of the box. Cloudera does provide. I'm not sure about Hortonworks. You can try with Hortonworks repository also by googling it and then creating the repository of Hortonworks and using the version related to Hortonworks. You can give a try. Okay, but Cloudera worked for me when I created the repository for Cloudera, and when I changed the versions related to Cloudera based versions, I'm able to run the programs on my Windows PC. Otherwise, you start getting into those null point exception and all those things because of the lack of native libraries. Okay, so that being said, let me know if you have any issues or questions. I will be able to troubleshoot and resolve those issues. Okay, it seems so. If anyone is typing, please say that I'm typing, so that I know that you are typing and I can wait. So Srinivas is asking, do we need to define Hadoop forms for Scala? Typically, no. So for example, if you go to my dot profile, there is no Hadoop form. So typically, no, you don't need to. In Scala, when you are trying to develop with Spark, you don't need to, unless you have a local Hadoop environment, and if you want to use it for some things, you have to do that. In this case, don't try to do too many things on your PC. Okay, try to follow my instructions and take it forward. Which program?
Word count.
Can you share your screen and can you show me?
Yes, like I've done a simple app.
Yeah. Let me make you the presenter, okay?
Okay.
Yeah, you are presenter now.
Okay.
Yeah, I can see your screen.
This is the program. Okay. And I have defined the output here, and I deleted the output. I'm deleting the output. Okay. This is where I defined the output.
Okay.
And configurations. I have given the simple app.
Okay.
And arguments. I have given the local and the file name as simple output, and this is when I have deleted it. Okay.
Okay.
And in command prompt, I have set up these things like dir. First, I set up what is that src.
Okay.
Int main in build.scd. I have given this thing like type. Given what I have done in type build.sbt. I have given the parameters like impulse for Scala version 1.0.
Yeah.
Scala version 2.11.8 and library dependence, and then I typed SBT package, and then I typed SBT
Okay.
That next command you have given, right? That when I type, then all this thing has been created. Once done, I have defaulted this thing, and then I copied this program, and
Okay.
then I have uh, run as set the configuration and run as Scala application.
Okay.
Can I run it again? Well, I'm running it again.
Yeah.
The first error I was facing was first error I was facing is scanning null bin utilities is in adaptive libraries. Cannot
Yeah. I think
locate execute.
again it is related to the same issue. I think even for Scala, you might be running into the same issue, which I have explained with respect to Eclipse. So probably you might have to create some dependencies as part of your build.sbt. I will troubleshoot this issue because I never ran in Windows. Okay.
Okay.
So it could be the same issue. But before that, let me do this. Give me the control. I asked for the control. You can
One
just
second, one
accept.
second.
No, no, I already asked you.
Oh, okay, okay. Sorry. I approved it.
Okay.
So I
Okay.
saw one of your old video and they told like do Hadoop libraries. So I set up that also, but it also facing the same issue.
Okay. I will troubleshoot the issue and I will come up with the solution very soon.
No, I need to delete it. Otherwise, it is.
Yeah, yeah, it will come. So it is creating the directory then. It's not okay. Delete the directory.
I'll delete it. Control is not coming to me.
You have to go top, I think. You have to go.
Otherwise, we can
No,
do
no.
different file name.
Okay, that we can do.
Output file name we can do simple dot output to or something.
Yeah,
Right?
yeah.
So instead of doing all these things, arguments give output 2 or 3.
So one more thing you can do is yeah, I think it's the same issue. Okay. Yeah, it's the same issue. Could not locate executable null bin winutils.exe. So I will troubleshoot the issue and let you know. And one more thing we can do is yeah, these issues are coming only in Windows.
Okay.
Also, these are not showstoppers if you think about it, right? Only you are not able to save it as text file.
Yes,
Other than that, everything else will work. So I will troubleshoot the issue. Meanwhile, you can
comment it out.
yeah, you can comment it out, and make sure you practice with the interpreter as much as possible, because as part of the certification, some certifications they might not provide the IDE, and even if they provide the IDE, they might not provide whatever you have practiced. So always better to practice with the this one, and it will give you a lot more flexibility also. Okay. Yeah, then I will troubleshoot this issue and I will get back to you. I think it's the same thing. Probably we might have to, we should be able to resolve the issue by creating the library dependencies also as part of the build.sbt, or probably we might have to set up Hadoop, and we have to point our Spark to that Hadoop binaries with Windows native libraries.
Okay.
Okay.
Got it.
Anything else?
No, as of now, that is fine.
No, for others, see, if anyone have any other thing, let me know.
And Durga, for next class, can you just explain in something in what is that in our testing thing, right? Because instead of in using that, so that you can practice there also, right?
What is that I didn't get you?
Like we have the
CloudX Lab.
thing, right?
CloudX Lab.
CloudX Lab.
Yeah, I will demonstrate in the CloudX Lab next week. We will use Scala IDE to develop, and then I will demonstrate how to run it on that in the yarn mode. Here we are running in the local mode. We have to run it in the yarn mode. We have to make sure the data is in HDFS. We will go through the entire all those instructions as part of the next class. Okay. Okay, then thank you very much. We will catch up tomorrow. Have a nice one. Bye.